Okay. Welcome to today's colloquium. Professor P. Vishwanath, who is the speaker, has written a detailed biography of Professor B.V.Sreekantan and would be highlighting how Professor Sreekantan was instrumental in building a strong foundation in cosmic ray research, underground muon experiments, and high energy physics experiments in India. Before we begin, there are a couple of things that we wish to inform you. If you have joined this colloquium via YouTube, you're requested to please post your questions on the live chat. If you're joining us via Zoom, please post your questions in the chat box as well. We shall be monitoring these chat boxes for questions and providing them to the speaker. We look forward to your participation in the colloquium today. Now we have Professor Arun Grover with us, who has generously agreed to provide his thoughts on the biography. Professor Grover specializes in condensed matter physics and was associated with TIFR since 1972. He was a professor at TIFR and went on to become the Vice Chancellor of Punjab University before superannuation. I'd like to request Professor Grover to share his thoughts with us.
Good evening, everyone. On the occasion of a special colloquium titled B.V.Sreekantan, a pioneer physicist, by a senior colleague of mine from Colaba campus, Professor P.R. Vishwanath. I consider it a great honor accorded to me to briefly address all of you before Professor Vishwanath shows us selected glimpses from the biography of Professor Sreekantan, which has the same title. This book was completed in April 2019, about 6 months before Professor Sreekantan passed away on October 27, 2019. Just 4 days before the commemoration event held at Colaba campus to mark the completion of 50 years of TIFR Graduate School in Physics, which was formally commenced with mandatory coursework, etc. in 1968. Professor Amit Roy, who is there with us, he was the coordinator of that event, and he is indeed from the first batch of TIFR Graduate School. So we had all missed Professor Sreekantan's presence during the 2-day event on November 1 and 2, 2019, which was attended by Professor Jha, Professor M.S. Raghunathan, Dr. Sukumar Banerjee, Professor T.V. Ramakrishnan, and several other dignitaries of TIFR. They had all recalled their association with Professor Sreekantan while paying tributes to him. Dr. Vishwanath had been enticed to write the biography of Professor Sreekantan by Mr. S. Balachandra Rao, the Honorary Director of Gandhi Center for Science and Human Values, embedded in Bharatiya Vidya Bhavan, Bangalore. As Dr. Rao wanted to disseminate the information on the persona of Professor Sreekantan far and wide, so that some young students would travel to National Institute of Advanced Studies in Bangalore to meet Professor B.V. Sreekantan, where he continued to work till his very last, up to the right age of 94 years. I had the privilege to review a book on Homi Bhabha, authored by Mr. N.D. Sharma and the NIAS director, Professor Baldev Raj, whose foreword was written by Professor Sreekantan in 2019, after the passing away of Professor Baldev Raj. This was Professor B.V. Sreekantan's commitment to his colleagues. I have joined today's colloquium in the online mode, and the organizers had a wide choice to substitute for me in this online mode. So I would like to thank M. Krishnamurthy for inviting me. I had joined TIFR Graduate School in 72, as was just told a little while ago. And one of my batchmates was assigned to work with Professor Sreekantan. A year later, Professor K.P. Singh also joined Professor Sreekantan as a graduate student. And K.P. and I were together at TIFR, and we are once again together in Chandigarh, Mohali after a time. Professor Vishwanath had joined Sreekantan's group as the new buildings came up in Colaba in 1962. And he closely worked with his colleagues in the cosmic ray experiment set up at Polar Goldfields for several years, before he decided to proceed to Michigan for his PhD and to Maryland for his postdoc. He returned back to TIFR to join high energy cosmic rays an extensive air showers group headed by Professor Sreekantan in 1977. Given Professor Vishwanath connect with Professor Sreekantan via his elder brother, P.R. Brahmananda, who was a close friend of the elder brother of B.V. Sreekantan at Bombay University, namely Dr. B.V. Krishnamurthy, and the close connect of Professor Vishwanath's wife, Gayatri Vishwanath, with the family of Professor Sreekantan from Nanjing Guru. Dr. Vishwanath had been rightly chosen to pen down the biography of Professor Sreekantan. The biography is not just about B.V. Sreekantan, it describes the life and times of happenings in wide range of scientific topics of interest to Dr. Sreekantan in Bombay and elsewhere in the world, along with the descriptions of numerous well-known colleagues and contemporaries of Sreekantan. I am tempted to add that this book is as informative and educative as the biography of C.V. Raman by Dr. G. Venkatraman, which is titled as Journey into Life. So this is Journey into High Energy Cosmic Rays and Astronomy Research in India. So G.V. also wrote a biography of Homi Bhabha titled The Magnificent Obsessions of Homi Bhabha in 1994, but that book was a much shorter one. In the foreword of the Vishwanath's book, Professor Ramnath Kaushik, the product of the TIFR Graduate School, writes that reading through the biography of Sreekantan gave him the same edifying experience as reading through the biographies of Nobel laureates S. Chandrasekhar or Marie Curie. Kaushik adds that Sreekantan's scientific activities had been forerunners or have run parallel to 3 Nobel Prize winning efforts. So this is what all we are going to hear from Professor Vishwanath, and I am eagerly looking forward to his presentation. Thank you very much. I have concluded.
Professor Vishwanath, would you like to begin? Thank you so much, Professor Grover, for sharing the thoughts. And I'll now request Professor Vishwanath to please.
Thank you very much, Dr. Chatterjee and Dr. Krishnamurthy and others for inviting me to Hyderabad. And I should thank Dr. Grover. He initiated this move. And also, just now, he gave an introduction to the book. I'm really thankful to you, sir, for saying good words about the book. And one more thing I would like to add is that it's also, I think I wrote for students also. That's why probably it's bigger than the normal biographies. And so for each subject, I think I gave some introductions, which probably students can read, and because that will lead them on to the research part. Okay, I'm speaking from Bangalore, and it's raining here. My talk is titled Pioneer Physicist Sreekantan. And somebody suggested some time ago, you could even say it, Cosmic Rays to Consciousness. And I might, the plan, excuse me. Why is it not going ahead? Okay, sorry, some hiccups. Plan of the talk is some introduction to cosmic rays, TIFR, early days, and Dr. Homi Bhabha. And then Sreekantan himself, the early days. Later, I will go on to the experiments, muons and neutrinos at KGF. Probably I'll take a little more time on that particular thing because It represents tells you the problems people faced during those days. Later, high energy physics activities at 2T, X-ray astronomy at Hyderabad, and gamma ray astronomy at 2T, Pachmari, etc. After that, I'll say a few words about him as director. And later we will see what all those fields are doing now. That's why I call it the legacy. And back to Bangalore, and where he joined NIAS and things like that. I start my lecture talking about the International Cosmic Ray Conference in 1963. How long ago? Almost 60 years ago, in Jaipur. The left part of the picture shows Pandit Nehru talking to a Japanese astronomer, cosmic ray physicist, and Professor M.G. Menon here. Here I should point out Professor P.C. Agarwal, who later took work with Sreekantan. And here in the audio, here on the dais here, are the leading lights of cosmic ray work at that time. Of course, Professor Bhabha, Professor M.G. Menon. This is Vikram Sarabhai. I think this is Professor Hayakawa from Japan. Sreekantan, I'm not very sure about this. And this is Dr. Devendra Lal. Why I start with this slide is essentially because as an introduction to cosmic rays. It showed the importance of India was getting in the field of cosmic rays, and how, I mean, this particular, I just joined that year, and it was for me as there as a volunteer handling my, handing mic and things like that. The conference was very well organized, lavishly, I would say. Evenings with Ravi Shankar, Yamini Krishnamurthy, Mrinal Sarabhai, etc. But final day conference banquet was Pandit Nehru. Everybody was thrilled, obviously. And he came from Delhi to inaugurate this meeting. This also showed how close he was to Homi Bhabha. So with this introduction for cosmic rays, I'll say a few words. The discovery, you see what happened, what used to happen, people used to work on radioactivity in the early 20th century. Actually, early 19th, late 19th itself it started, but anyway. And there was always disturbance in their counters. So when finally it was found out that a lot of particles from atmosphere are coming and hitting the instrument. And then this gentleman, Austrian gentleman called Victor Hess, went up and finally discovered cosmic rays are coming from space. That was in 1912. I'll let you in on a secret. Even now, today, we do not really know where these particles come from. We have guesses, of course. So next, the question which bothered people a lot were, what are those particles? Were they photons? The great Millikan, the oil drop person, oil drop experiment, who did, he used to say, no, they are photons, but means gamma rays. Or other people used to say, like Arthur Compton, to say charged particles. So this was the thing which went on almost till 1940s, when our people take over cosmic ray work. I mean, start participating in cosmic ray work. Now, you see, cosmic ray work at that time essentially involved finding, looking at interactions and seeing whether there's anything new. As you know, at that time in the early 1930s, the proton and electron were well known. Neutron was just then being discovered by Chadwick. And in around same year, I think 1932, positrons were found in cosmic rays. I won't go into detail because I'll take too much time otherwise. And positron is essentially the antiparticle of electron, as you know. Now, I'll talk, of course, a few more particles, but one should note for years to come, cosmic rays remain the only source of high energy particles. The next antiparticle would not be confirmed for another 22 years, and it needed accelerators. Another particle which was very interesting and which is going to be very important for us was called Muon. It's called mu meson. Professor Sreekantan, until the very end, he used to call them mu mesons. They were thought of as mesons during those days, but in the 50s realized they're not muons and they're more like, they're not mesons and more like electrons. And they were discovered in 1936, and they found that they're both positive and negative particles. And so they guessed that mass must be greater than electron, but smaller than that of a proton. As I probably will tell you later, Professor Bhabha had actually talked about this at that time, but his work has not been didn't get much prominence. Okay, another particle which is important for us. There are going to be millions of particles, as we all know, but these are the particles which are going to be dealing with. They were predicted theoretically, and they were found. Now, the technique used, you see, the earlier were cloud chamber, where essentially because of ionization, you see the particles. Here is the same thing, but of course, it's in the nuclear emulsions. There's some particle coming and decaying and giving rise to muons, and this particle was found to be pion, was called pion later, and it was done by Powell of the Bristol group in Britain. So particle detection, this could happen because if you see this graph, this picture, cosmic rays come under atmosphere, nucleus, it will hit some maybe proton or something, it will come. So it will hit the nitrogen nucleus or something like that. So several particles are produced. These were what were found. Of course, these will come down, as we will see later. And they were somewhere you put your equipment here, you find all these particles. So here is a year. I don't know how well you can see these because I don't know how many people see this through their mobiles. I have no idea. So the year here, and when the particles were detected, that's the electron by Thomson in the late 19th century. Then here you have the neutron, positron, muons, and pions, and kaons. We won't worry about the other particles. So this is the thing. So cosmic rays were very important because people could look for new particles. Now, our own Indian participation, if I leave out some names, please excuse me. Partially, I'm not aware of it, and partially, I don't have time. The important people here are Dr. D.M. Bose of Kolkata and Dr. B.V. Chowdhury. And they work with nuclear emulsions. Nuclear emulsions are essentially good old photographic plate which started with, you put different elements in there. They may have discovered the muon. I use the word muon, may have discovered, because there have been resolution problems, and I still keep seeing various statements about this. And but it's possible they discovered the muon in late 30s. And they also pioneered some analysis methods, and Powell really refers to that. And their work represents the first approach to the scattering method of determining momenta of particles by observation of tracks. This is what Powell says in his Nobel Prize Nobel lecture. And this is Dr. B.V. Chowdhury. I was lucky to see her in later at KGF. This is Bohr and Dr. Bose. Another person who was studied cosmic ray work was Dr. Gill. He got his PhD in Chicago under Arthur Compton, and he came over to India, and he created a lot of good facilities for work in cosmic rays, development of counters, etc. So this was the scene when we now go to 1940s, Indian Institute of Science. There, Professor C.V. Raman was there. He had come in 1933 or something from Calcutta. And but he himself was not interested in cosmic research, but he wanted to build a group. And Millikan, as I told you earlier, it seems he used to visit India maybe twice, thrice, something like that. So I think he probably there had some discussions, and he wanted to start. And Homi Baba, we'll talk a little later about him, came back from abroad and also became a reader in Institute of Science at that time, 1940, 3940. Vikram Sarabhai as a student was also doing experiments. Here you can see them, Sarabhai. This is from, of course, Baba, and I think it's Bhatnagar. Baba himself started doing some cosmic experiments with balloons while in Bangalore. This shows him in Central College in Bangalore. Okay, now Baba got an idea of starting his own institute. As he wrote to Chandrasekhar, Professor Chandrasekhar of Chicago, the great astrophysicist, we want an intellectual atmosphere approaching what we knew in Cambridge and Paris. And so he wanted to start an institute. Earlier, in a few months, it was there in Bangalore. Later on, it came to Bombay. Those days it was Bombay, now it's Mumbai. And it was on Pedder Road for some time, I think his own bungalow, and shifted to Old Yacht Club near the Gateway of India in 1949. Now, the foundation for this intellectual atmosphere was laid in this Old Yacht Club. Various activities started, including mathematics. Professor D.D. Kosambi was there. This shows the Old Yacht Club premises. I don't know, it's near Gateway. Some of us lived there as in the hostels there. So what was the thing is, the students who joined there later, as you probably know, later headed various science programs in the country. They're all illustrious people. And Homi Baba had various distinguished scientists, which helped the students a lot. Bohr, Pauli Dirac, all great names, Gell-Mann. And in 1950, he arranged an international conference. I think it's on cosmic rays. Exactly, I do not remember. But of course, those days, cosmic ray, high energy physics, etc. I'm told it was one of the first, or the first of that type. Many leading scientists came, Blackett with us. And this is, I'm mentioning that because this is gave fillip to activity in India, and it enthused students like B.V.Sreekantan. I'm taking a little time to, this is about the early parts of TIFR, which I don't know how many of you may know. If you know, please bear with me. Now, Homi Baba was, of course, extremely capable person, brilliant, etc. But he had good friends also, and he could achieve a lot. I mean, he could achieve much more. That's Pandit Nehru, who was the Prime Minister of the country. And here in the lower slide, here in the lower picture, he's with J.R.D. Tata. So the TIFR, the new building, which we see today, which, as I said, for about 10 plus years, it was in Old Yacht Club. 1951, 54, foundation by Pandit Nehru. And there is a nice biography by Baba by one Chintaman Deshmukh, apart from several others by Indira Chaudhary and others. He says, for example, at every stage, Baba participated in the construction process, and he made his senior faculty to get involved. And Sreekantan told me that he was very much involved with that. And with very meticulous and adamant refusal to make compromises, as people knew who know him can attest to. And the left part, I mean, as you enter, it had big rooms. Initially, it's Baba. It seems to care which group gets which rooms, etc. And that's where the experiments. And in 1962, this is the inauguration by Nehru. And this, of course, are the new pictures you probably have seen. And this is the famous mural by Hussein. There are some interesting things I have written in my book, I think interesting, about my first few days in TIFR. I joined actually very end of 62 December, so I consider basically 63, and how we were all awed by the great building and the great paintings, etc. So this shows some of the colloquiums. This is taken at different times. I cannot really gauge exactly the time here. And I think people who, if you like, you can go back after all this, look at the YouTube. There are plenty of people here who are all the leading lights of those days. And this is Peters, I'll come to him later. And this is Professor Pavel, Sarabhai, Yashpal, Menon, Swarup, Kaushik. This is Yashpal, much older, I think. Professor Venkatragavan, Sreekantan, Virendra Singh, Daniel, Menon. This is Professor Narlikar, Professor Ramanam. And I'm just showing you some of these people because these were all very important people. And they did a lot of science also. Okay, now we come to the student who joined Bhabha in 1949. There's a place called Nanjing Guru in south in Mysore in Karnataka. And it has got a great river, and this shows the river beach. But what's more interesting for us, I'm showing you a wrapper. This is actually a tooth powder, which is very common in our younger days, and here it's still very common in many parts of Karnataka. This particular pouch, this is had tooth powder, which was very. The reason to put this here was it was by researched and really made by Professor Sreekantan's father, B.V. Pandit. He was a famous Ayurvedic doctor, and he also did a lot of research, and that's how some of the things came out, including his tooth powder. And Sreekantan came from a very large family, highly educated people, like economists, doctors, engineers. Sreekantan tells me one of his brothers is a communist, and how he was interested, how he really developed interest in Marx. And, like as you can see, as you may see or may not in the very end, he was always reading Shankar also. So he was the type who would read Karl Marx and Shankar. Very erudite people, I met some of them. And these are the men and the women and the spouses here. So he studied earlier in Mysore. Of course, Nanjing Guru was a very small place. He could not have colleges there. Studied earlier in Mysore and later in Bangalore. It's a famous college in Bangalore, very old Central College, where people like C. Rajgopalachari, etc. studied. And he did his MSc. Sreekantan was very good at games. He was very good at tennis. He represented the university and the state, it seems. And later he had a 1-year stint at India Institute of Science. He did in the electrical engineering department under Dr. Chatterjee. Then he wanted to do something else. So the institute places were PRL, TIFR, etc. I think he got admission everywhere, but in 48 joined TIFR. Now I don't think you can read this lower one, but I'll read for you. So GM counters, I think all of you know what they are. They essentially detect ionizing radiation, perhaps world's best known instrument. People at that time, this actually the lower, this thing which most of you probably cannot read, talks about Fermi. Good old Enrico Fermi in the 1930s when he was doing experiments with neutrons for artificial radioactivity. He himself used to assemble crude Geiger counters by cutting the aluminum cylinders, etc., etc. So that was one of the things which a lot of people did, experimental scientists. Incidentally, I read somewhere that Pauli called Fermi a quantum engineer. Okay, so GM counters making that and was one of the big things in experimental science those days. And I already talked about muons. Now, whatever I'm going to say on this slide is all known later. At that time, when I'm going to be talking about Sreekantan's experiment, nothing was known really. And how, its mass was guessed at, etc. And its interaction, its decay was really not known. W bosons certainly not. And all that was known as it goes through detectors. This is some later detector, but all was known as goes through detectors. And so this is muon, and as I said, called mu meson wrongly those days. So Sreekantan joins TIFR. So after Baba asked him to find the muon lifetime. Muon lifetime was not very well known. It was known, I'll show you the accuracy later. So he just mentions, for example, he had to talk to the seniors, and so he mentioned his experiment, drew some circuits, etc. But it went on for 3 full days, and how people like Koshambi and of course Dr. Baba, etc., were deeply involved with that. It just shows how the seniors, of course, it was a small environment, of course, and so there was deep interaction between people like Baba and the students, Sreekantan. So now, how does Sreekantan do it? This is a kind of slightly romantic thing, and plenty of discarded electronic components. World War was over just then, a lot of surplus available, left behind by the military people in Bombay, Chor Bazaar. He says Raja Ramana and I, along with some other colleagues, used to venture into these areas in search of our needs. And in those days, one did take a risk in going there because of communal disturbances, etc. Anyway, with these disposal equipments, we built our amplifiers, oscillators, etc. Also, they started counter-production. I want to just stress one thing here. How this is early 50s or late 40s. How this particular philosophy was there in the institute for quite a few years. As much as possible, use whatever is available around. And even when I joined in the early 60s, that was the philosophy that, and also, as Sreekantan told me several times, money was really in short supply. We have to realize that India was, one would call not an affluent country. And so we really had to learn to work with whatever we had. And so his first experiment is a lifetime of muons. I'm not going to tell you exactly what these are. Essentially, muon comes in, there's a magnetic field and bends, etc. Just see the circuit diagram here. I don't think you can even see any detail here. But full of vacuum tubes those days. Transistors came in the early 60s. And you can see an oscilloscope tube here. So he got a good value, 2.24 plus 0.15 microsecond. Rasi, whom I will talk about a little later, had gotten similar within error bars, but some other people had their lifetimes way beyond. So Sreekantan's lifetime experiment confirmed some of the earlier results. The present result is not, disagrees with the present result, which is given here. Okay, so as I said, ingenuity in the face of scarcity of science. Sorry for there are some typing mistakes. Instrumentation was very important in a newly independent and not an affluent country. So Naranan, whom joined little Sreekantan later, he says counters are mass produced in the glass blowing section, were available for cosmic ray experiments. and with plentiful war surplus, as I said. And there's a book called Elmore's and Sands, which is a must reading for us when I joined the institute. Sreekantan had set up, I would like to stress, one of the most sophisticated cosmic ray experiments at the time. So we had all this now. So what's the next step? Lifetime is measured. So 1950, I told you there is a big conference in Bombay in Old Arch Club. And so I'm sure there are plenty of discussion about various things. And nobody knew much about any of these particles. So Professor Baba tells Sreekantan, why don't you take your muon detector underground and see whether there are any new particles apart from muons. Also, do it is a muon decay? Is it a two-body decay, three-body decay? Can you answer these? So Sreekantan, the next step, he goes to Kolar Goldfields. Kolar Goldfields, a little bit of history here. It started in, they say during Gupta's times, and then Tipu Sultan also used it the same. But for our purposes now, modern mining was started late 19th century. A British company managed it till 80. And Karnataka, especially old Mysore state at that time, was lucky, got electrification in 1902. Bangalore is in 05. And so KGF mine, second deepest in the world, 3,000 etc. meters depth. Actually, it's a huge thing, 100 various shafts, shaft means to go down. And the tunnels, 1,000 kilometers, etc. So it's 1,000 tons of gold have been excavated till today. I don't know how much it is in rupees. So here is the Gifford shaft, one of the well-known shafts to go underground, and there is one of the tunnels. So you really had to set up your experiment in a tunnel. Please don't think all these tunnels were this nice and all that. I also worked on some of these, as I'll tell you later. We had a lot of water, we had to wade through water, etc. But it was adventurous. So Sreekantan was asked to angular distribution of muons. It means how many muons per different angles, arrival. And so he gives a table here, whatever it is here, a different degree, and then writes a letter to Professor Baba saying, respected sir, etc. Of course, I don't know whether present students write to their professors or directors using respected sir. So this was from his letter, and he did very well. And slowly 2 people joined him, Professor S. Narayanan earlier and Professor Ramanmurthy. They all did their own. Ramanmurthy did a lot of interesting things later. Narayanan was, he had special interests. I don't know, it's called Kolam in Tamil. He worked on columns. It seems there is a theorem attributed to Narayanan. So there are other interests. So that depth intensity measurement started. That means essentially how many muons at each level. And they themselves saw muon rate was going down rapidly. And so this experiment was taken up later by Narasimham, and Ramanmurthy continued, and Professor Miyake from Japan. And they did one of these very classic, they just essentially went deeper than what Sreekantan did, and slightly more sophisticated instruments. Here is the instrument, a simple scintillator here, plastic scintillator, top and below, and here is the flash tubes, and essentially you record these signals here. So here, the important thing is that when they went very much down, there is no count for two and odd months. So what it does tell us, it says that you can look for neutrino events here because there's noise is very much less. I just show you a plot here. This is essentially depth intensity, means number of muons. Exactly, don't worry about the actual units here. But here is what is important, the depth. And there are several this is a modern, new plot actually, but doesn't matter. But the deepest thing here you can see is the KGF point. Okay, so it set us this for to do work on neutrinos. Neutrinos today we know, of course, comes in various sources are there: Big Bang, terrestrial, reactor, and solar neutrinos, then atmospheric, etc. And then later the galactic, extragalactic, nowadays being actually the Antarctica experiments are pursuing this. So neutrinos come from all types of places. What uh, the colleagues in KGF tried to do was the atmospheric neutrinos, and they were in the GeV energy range. This is the energy range. This is come cross section, don't worry. Okay, neutrino detection. Now, neutrino, as all of you know, was Pauli had suggested it in the early 30s as for recipe for as a this thing for beta decay problems, and for 20 plus years it was not detected. And Reines and Kavan in 1955 actually detected it with the New York reactor neutrinos. This is Professor Reines, who got the Nobel Prize later after 40 years. And that was the electron neutrino. Frankly, actually, people did not know how many neutrinos were there. And there were guesses as there was must be one more neutrino. And the muon neutrino, here is something about electron neutrino in these green boxes, was discovered in accelerator by Letterman, Schwartz, and Steinberger. They also got Nobel Prize, but faster than what Reines did. Reines, incidentally, was a rival for most of our KGF experiments. And he was in Caltech, and not Caltech, Case Western, and then later in Irvine. So we just see the year 1962. So just then, people realized there are two neutrinos, and still not much was known. So the KGF group, they decided to look for neutrinos here. And here are the other people: Narasimhan, Professor Menon, Miyake from Japan, Professor Wolfendale, and one more person was there, if I remember, Achar. I'm sorry, I don't have his picture here with me. This is the instrument here, and you can see the scale by the people here. Essentially, plastic scintillators and tubes, flash tubes here. So you look for tracks left to right, right to left, etc. Okay, so atmospheric neutrino was, they were discovered, I think 18 or some number was there. And wow, what is this? Why is this not going ahead? I'm sorry, just please bear with me. And okay, something worked. So in memory of that, the Royal Institute of London, they actually had a gold medal in, I think, 2015. I'm showing one slide, one part of the medal, and 50th anniversary of the discovery of atmospheric neutrinos. I think this experiment was really brought the Sreekantan, Menon, and other people into Menon, of course, had worked on K-Meson, that I'm not going to talk about it. So it made the group very visible, and I heard it get a lot of press at that time, and it's still remembered by the historians. It's important, of course, for we'll see later some other experiments were done here. Okay, this I'm not going to talk about. I think I'm. So in mid-50s, Sreekantan writes his PhD thesis, gets married to Ratna Sreekantan, goes to MIT to work with Bruno Rossi. At that time, still K-Mesons were mystery. He also goes to Ecolic Lab and works on the instruments there. The importance here is his great significance in Sreekantan's life because it gave him enormous confidence. This instilled in him the courage to conduct frontline experiments at par with the West. That's important. And so this is very important from the view of Indian science, since it inspired him to take up various activities. This we'll see later also with X-ray astronomy. Incidentally, Professor Sarabhai, Yashpal, they all used to visit Bruno Rossi. Rossi was a very interesting man. He should have gotten the Nobel Prize. Unfortunately, he passed away earlier. And he's an Italian scientist. He did the early time dilatation experiments, proved Einstein right, and discovered extensive earths. I'm going to talk about it. He did lifetime of muons, as I showed, founded X-ray astronomy, etc. So he was a very interesting man, and he did a lot of work. This is Professor Rossi, and he is with Enrico Fermi. There's something here I want you to read. And because in the end, it's again, I'll talk about it. He called it the age of innocence. Fundamental results could be achieved by experiments of an almost childish simplicity. This is a very important thing to note. He's also called father of high energy astrophysics. His book called High Energy Particles is a must read. Actually, for us, when we joined, this and Elmore Sands were the two Bibles we had to read. Of course, there's only one Bible really, but anyway, the particles physics, you had to read this, and then the electronics, Elmore Sands. Now I come to another activity. I am, as I said, I talk about several activities of Professor Sreekantan and his groups. The high energy physics activity of TFR, one Professor Peters, Bernard Peters, had come to, actually it's a long story. He came from US, he was actually went from East Europe. He escaped concentration camps or summer camps, went to Robert Oppenheimer, worked with him, then came back to India. Baba invited him, and he did a lot of good for TFR. I met him much, much later when he was much older, and he remembered TFR with a kind of almost had tears in his eyes. And here I want to show you Professor Sreekantan, Devendra Lal, who later headed PRL, Yashpal, who was the big educationist, and also some activities in PRL were connected with, not in Ahmedabad, with satellite communications. So these people are the leading lights of high energy physics those days. And there are several interesting papers by Lal, Paul, Peters, etc. But I will talk about the what. Those are all mostly immersion studies. Okay, now high energy studies are better done at high altitude labs. And there were, from cosmic ray work, when it started, many interesting labs that all came up at great heights. I mentioned some, including Echo Lake, where Sreekantan worked. Incidentally, I also worked much later there. I just want to quote here something from Sarabhai's biography by Amrita Shah, how it was done. In August 1943, an expedition was undertaken to Kashmir in order to find suitable locations where high altitude cosmic ray experiments could be performed. Now, this expedition, as they call it, had 90 people. People went on horses, several. There were cooks, other helpers. That's the way, of course, Professor Sarabhai was, an aristocrat. So he took all these people. But the point was that it was necessary to do at high altitudes. And later, of course, probably people could not take many horses there. And so they decided to have permanent field stations at high altitudes. And one such was Ooty. And Baba asked B.V.Sreekantan to look for a site in the Ooty area. I think he was very familiar with it. And then the governor very graciously gave some area in Rajbhavan for this work. And those days were, big people used to kind of give and take a lot of things. This is the cosmic ray lab near the famous botanical gardens where a lot of film shooting is to take place. So OT efforts, I will mainly highlight some aspects. Innovative instrumentation was important, very important. Then some what's called airshow studies, and then gamma ray astronomy later. So one of the important instruments they built was called Tutola. I'm sorry if I'm going a little deep into this thing, but some of these have to be mentioned. This is essentially to measure the energy of a particle, and it's a forerunner of the calorimeter, which is today everywhere in all high energy physics experiments. I'm told this is one of the first built. Russians also had, but I don't know whether it's theoretical or also was there. So essentially, it's a lot of detectors here. Those were scintillators or liquid scintillators. And so you find how many particles were there, etc. Essentially, a particle comes and dumps all its energy, and you measure the number of particles, you get an idea of energy. This is one. Then another very innovative thing was instrumentation with large cloud chamber. At that time, I'm told it was the largest in the world, and used many years by TFR group for interaction studies. This shows the Pandit Nehru with the thing in, I think, Bombay. This is the actual cloud chamber. So these are some nice pictures. I'm sure there are nicer pictures, but I could not get them. And Sreekantan himself used to say there are a lot of nice pictures, I don't know where. So you can see one particle coming and interacting. This is what a cascade really is. This is, of course, lead, iron, etc. But it happens in air, as we will see soon. So you just see how measure all these particles, then you get an idea of energy. Same here. This is probably a muon. Okay, now we come to cosmic rays. I told you already about cosmic rays. But the great thing about cosmic rays is it has particles with enormous energy. We have these electron volt as the unit. Just to compare, 1 electron volt is the energy of a light optical photon you see, and 10 to the power of 20. This is energy here. This is the energy spectrum given here. This is some type of flux units. And most of the particles we see on ground are essentially from some of these energy, 10 to the power 14, 15, 16, etc. And this is what TIFR and many groups studied, and primary particles of these energies. They create air showers, as I should soon come. And at the very high energy, which is today the very interesting part, but takes lots and lots of time. What happens to the very high energy cosmic rays, ultra high energy? Okay. So, as I already used the word air showers, essentially what happens is the cascade you saw in the in the cloud chamber happens in atmosphere also. That produces lots of particles. Now, how many particles? Depending on the energy, 10 to the power 14, 15 electron volt, 10,000 to a lakh at least. So you what to do is you build detectors, and so you measure their energy and other things. And the thing is here, so it can help us. You see, as I told you, it's beyond accelerators. Accelerators today start at 10 to the power 13 to 14 electron volts. And this is the cascade of particles here, how they go up and come down, just as happens here. And so two aims are there for ratio studies: particle interactions and primary composition. That means what is the what type of particle is coming in, and from then you guess how it's produced, etc. And so these were the two aims of ratio studies. And our group, quite a few members were very actively involved in many experiments in this field. So this is the this is Professor Emir Rao. He worked in OT earlier, later KGF. Professor Tanwar worked in OT. They're all there in the mid-60s. They're all the pioneers of some of the studies. Professor Sreekantan wrote a book on extensive air showers along with Rao. This is the book. I think it's World Scientific. So some of the people here are there, some of the people who used to work. And I'll just show Professor Dr. D.T. Murthy, electronics we said, and this is Narasimhan, Professor Miyake, Apte, and I think this is Subramaniam. Here I can see Professor Sreekantan. I don't know how well you can see. I myself cannot see that well. So this is some pictures on those groups. Okay. Now I want to point out how it was done. Actually, I've already used the word Age of Innocence. It's important to note that these experiments like Muon work, high energy, air shower, later X-ray, gamma ray, gave training to many young physicists in various aspects of the experiment. Detector building, electronic circuitry, putting together experiment, data collection, deduction, data analysis, Monte Carlo methods initially that was initiated by the TIFR group, finally getting fizzing out, writing papers. Most of us did all these activities and those days. And later, of course, the PhD was always a byproduct of what you did. I know some of the people in Sreekantan's group took 10, 15 years to complete their doctorates, but that was all right at that time. There is no graduate school at that time. Okay, another thing Sreekantan did was in the mid-60s, he went to MIT again, to Ross's group. Rossi had several interesting ideas. One was X-ray astronomy. Why not go up in the atmosphere? You have to go up in the atmosphere to see X-rays. And he built simple instruments, as you'll see one or two. And in 62, he sent up a rocket. This is Giacconi, who got a Nobel Prize for it later. And just the rocket stayed for 5 minutes, but he did great work. They were very lucky, really serendipity. The strongest X-ray source they got, called SCO-X1. And B.V. joined the group in the mid-60s. He contributed to the identification of the source there. And more importantly for us, he came back and started the X-ray astronomy. So this is later, few years later, Rossi built a Uhuru satellite, and it essentially counters and all that. And they discovered 300 X-ray sources. Okay, now TIFR had a history of high altitude programs, and they did it with balloons. And Dr. Gokhale, Professor Menon, etc. were involved with it. And a laboratory in your own Hyderabad was started there. That was useful later for X-ray and infrared work. These are some of the people who were there early days. Agarwal, Manchanda. This is Professor Sreekantan with Oda, a Japanese pioneer in astronomy. Here is Sreekantan during a balloon launch. So therefore did many things. I'm just, as I said, I'll just go show you, just give you a glimpse. This is their instrument. And so they detected the famous Cygnus X3, a black hole, and flares from that. And what they did later about the spectrum, etc. This is just, as I said, a glimpse of what they did at that time. Okay, another thing Sreekantan started, and Professor Ramamurthy was there with him and others, was gamma ray astronomy. Now, X-ray is about KeV energies, okay? Gamma ray is much later, MeV and 100 GeV, etc. Some of it is done with the satellites, there is a satellite called Compton, later for me. And gamma rays were studied with what we call atmospheric Cherenkov technique by ground-based instruments. This was started in 1960s in very small scale. Actually, it was a means to study cosmic ray origin, but gamma ray astronomy by itself took off later. The problem in this field, as many of the fields really, are the signal is very, very small, but enormous noise here. There are very few groups and very occasional success in this. And I will not talk about how exactly it is done, But what is very interesting is in 1968, pulsars were discovered. So I already mentioned signal to noise problem. People felt that signal to noise could be included if pulsar signatures were used. TIFR did just a 2-mirror experiment. These are just searchlight mirrors somewhere near Uti. And of course, they could not detect any sources. But it was, looking back, it was naive, but what I would call chutzpah. I mean, I don't know whether people use that word. Real courage and also very innovative, I would call it. This type of innovative thing is what really brought Sreekantan's group. They did several important things. This is a classic example for that. Just with 2 mirrors, of course, we know it's just naive, but that's not the point. So in Uti later, of course, there were more mirrors. They were used, and there's a small experiment in Gulmarg also with fewer mirrors. The PRL group had it, not LPRL. So this later was used in Pachmari, etc. So the air-short technique could also be used for gamma-ray astronomy. I'm not going to go into that, but that also involved a lot of several of us for a long time. Now this is the HECR group in 1980, high-energy cosmic ray group. I had come back in 79 from abroad. I just then joined. I just want to point out everybody here, just for old time's sake. This is Professor Shiva Prasad, unfortunately no more. Sreekanth Sinha, Sunil Gupta, who headed later the work in Uti, Professor Sreekantan, Raman Murthy, who passed away last year, Narasimham, myself, Suresh Tanwar, Nava Mandal, Acharya, Professor M.S. Rao, Krishna Swami. This is Professor Narayan, who again passed away just a few months after Sreekantan, who had worked with Sreekantan all his life. Of course, the group became bigger, but not much bigger. Okay, now I essentially have come to the end as far as science activities go. I look at it about 10 more minutes I have according to my watch, but if I take little more, please bear with me. Now, as far as administration goes, Professor Bhava died in 1966 in an air crash, as many know. Then later, Professor Menon was the director for 10 years almost. Menon had a lot of things to do in Delhi, so he left. Then Sreekantan became the third director of the institute, 1975 to 85. He was always, I have talked to several people when I wrote the book, and some of it is my own observation, but many from different people. He was always available, very important quality in a director. He would go around the institute every day, morning, talk to people. He was always good with union. As somebody put it, conveyed grace and gentlemanliness together with a concern for each individual. This is also important. That distinguished Sreekantan. He generally had a trouble-free time, as he himself told me once. And he started several new programs, essentially supported them and nurtured them. The very important thing is, I'm sorry, this is, I don't know whether you can see. The GMRT, Professor Swaroop's brainchild, and he supported and nurtured. Professor Swaroop was always, he talked to me later, he's very grateful to me. National Center, NCBS in Bangalore, Professor Siddiqui's idea, he supported. Samir for microwave, initially it was in TIFR, later it started. Then very importantly, Homi Bhabha Center for Science Education, which is the ideas of course pioneered by Udgaonkar Kulkarni et al. He was also in a governing council in Indian Institute of Astrophysics in Bangalore. The 1-meter Chandra telescope in Hanley was, he was there when supported, he supported that. This, as you probably know, is I think the highest or second highest, I should know. He also set up the Big Crest campus in Hyderabad, Hyskote. I mean, he himself said, no, I never set up, it's all Sri Kaushik did. And he also was helpful in initiated gamma ray telescopes in Hanley. As Professor Chitre, who passed away a year ago, mentioned, He has done more than his share for experimental science in the country. Here are several photographs with Professor Chandrasekhar, D.R.D. Tata, Dr. Venkataraman, President, and Professor Swarup here, Udgaonkar, Ananta Krishnan. These are with Manan, Tata, I think Professor Baba's brother. These are several people here, some of the registrars, Putran, Peralkar, Dr. Daniel. This I do not know really. And this is Professor Vijayaraghavan, Venkataraman, Subramanian. This is. So you will see some of the older people. I don't know how many of you recognize them. If some of the older people are senior people are sitting, they could probably see some of them. Okay, now the age of innocence really ends now. Experiments became much more complex and needed many more people. Physicists, a lot of engineers staff increased actually, very competent engineers. But we needed more physicists. This was a problem for many experiments in India and elsewhere, including TIFR. And collaborations became more and more necessary. Some of them are undertaken, some not. So here is actually, unfortunately, Age of Innocence ended early in West. Probably it went on a little longer in our country. This is the legacy of Sreekantan. I'm going to run through some of them. One was the famous proton decay. Some of the theories, gut theory, etc., predicted proton decay. So a very good instrument with proportional counters here. And this is a wonderful experimental apparatus, 6 meter cubic in underground, 2.3, it was done in 2 stages. It's called the proton decay experiment. They did a lot of work. Later, a lot of neutrinos were there, neutrino events, but as far as proton decay events, none were seen. By this group or several groups, some are even bigger experiments. Nobody saw the decay. So the upper limit is something like this now. Okay, B0 group also, our group joined and built the Muon calorimeter there. And I see it all as a legacy of Professor Sreekantan. And as far as X-ray astronomy work goes, 5 years ago, X-ray satellite was put up, and AstroSat, a multi-wavelength satellite, TIFR, IA, ISRO, etc. And I don't have time to go through the instrument, etc. There are several aspects. Some of the people here, I see KP Singh and Rao and the other. So this is just to show that this is working very well. CRAB was seen. CRAB, as some of you may know, is the most important source in high energy astrophysics. Okay, this just, I'm not saying just about our groups. You can see the field itself grew enormously. X-ray astronomy, 300 sources, early days, 1973. Now see ROSAT, it is 2000 plus. Oh, I don't know, 1 lakh plus sources now. Okay, UT cosmic ray, this thing was made much bigger. I think later Sunil Gupta was there. And it's doing solar physics now, apart from Airshore. They recorded solar flares. The Muon telescope is being used very intelligently. So as far as gamma rays things go, which I was part of, we built a gamma ray array in Hanle in Ladakh. This is one of the telescopes. We built 7. And much later, BRC group is building what's called MACE, much bigger instrument. And this is because this is the order of the day, as I'll just show you in the next plot. You see many life like that are being used now in all over the world. And in the next few decades, huge Cherenkov telescope array is coming up in, I think, South Africa. Huge thing. So all these fields, which Sreekantan kind of was helpful in starting, they've all done well. I would say, except for Airshore, somehow the phenomena itself has problems there. And except for that, probably. And so that's why I think Kaushik Professor Kaushik in the introduction, in the foreword, he said, these are all Nobel Prize type of thing. Neutrino work later got Nobel Prize, solar neutrino, atmospheric neutrino work, and X-ray astronomy got Nobel Prize later. So all this was started. I mean, I'm not saying they were totally initiated in India, but along with others, we started that work in India. Okay, now this is just to show progress in different astronomies, and not important now. Many sources have been found in all these different astronomies now. Well, 20, 30 years ago, we had none. So Sreekantan comes back to Bangalore, and with Mr. Sreekantan, and they settled down in their home in Malleshwaram. I'll show you the thing. He became a member of NIAS, National Institute of Advanced Studies. Dr. Ramana was the director. It seems he cajoled him to become a member. Now, started the Consciousness Studies group in NIAS. It's a big group now with many contributions. I'm sorry, my expertise in that field is very small. I can't say much about it. Sreekantan got many awards and he wrote many papers. I'm not mentioning all that. Padma Bhushan is one because the country gave. And he was with NIAS till the very end. Here are some pictures at the very, almost at the end of my talk now with Mr. Sreekantan, here and here. And this is with two young sons, Venkatesh and Ramesh. This is an interesting thing. Some railway, they're going, all these astronomers who are going to some conference, Professor Sreekantan, Professor Chitri, Professor Narlikar, Professor Dania. And these are some of his colleagues in NIAS, Rajaramana, Srinivasan, and others. I think Padmanabhan. This is in the this is about a few years ago. Some of us attended in TIFR when he was honored. This is Professor Bhattacharya, honoring him. So this is his picture with his grandson, Agastya. And this is his house in Malleshwaram. He passed away 27th October 2 years ago. He was a pioneer experimenter, as you saw, hopefully. Certainly a gracious human being. He was liked and respected by all. I personally miss his presence because I used to meet him once in maybe 2 months in the last decade or so. I used to go to his Malleshwaram house. He used to insist on making coffee himself, though it was really trouble for him. And he used to reminiscence about past. There are several things I have not written or not talked about, but I think it's he was there at the right time, at the right place also. As I said, it is the age of innocence, and we could do a lot with relatively simpler instruments. Thank you again. And
thank you, Professor Vishwanath, for taking us through the journey of Professor B.V.Sreekantan. At this point, we would like to...
I took 1 hour. Okay, yeah.
Yeah, it's perfect. So we have some questions here, and we would also we have enabled the unmute option. If you wish to interact with Professor Vishwanath, please go ahead. But before that, we have one question, and then I'll just leave the stage.
What should I, 1 minute?
Yeah.
Dr. Chatterjee, what should I do
No,
here?
I'm just Anushila actually. So you would have to click on escape, and you can actually stop sharing your screen.
Stop sharing the screen.
Yes, yeah. Yes, this is perfect.
Okay.
All right. So there's one question that has come on Zoom. What was Professor Sreekantan's view about closing down the Kohler Goldfield lab? Did you talk to him about this?
Yeah, you see, I mean, it was beyond him. Actually, the thing is, these people did the neutrino experiment in 60s, and some high energy physics work was going on in the 70s, some interesting events. And then the idea of proton decay came, started in 80s. I think it went on till early 90s. No, the one reason they had to, there are a lot of neutrino work done at that time. In the earlier neutrino experiment, of course, not many events were collected. In the later one, plenty were collected. And the point was not that they decided to shut down. They had to shut down. The thing is, the mines itself, the authorities decided there is no point in continuing the mining activity because according to them, not enough gold was coming out. And it was so just difficult to run. And I remember I had heard, not this time from Sreekantan, but much earlier, that Professor Menon talked to them and it said, you need, I don't know, remember 8 crores, some number like that, to keep the mines running. Of course, that was beyond TIFR's or any the Science Institute's budget. So he said that just had to be done, and they really had no option there. I don't, you see, and also today I'm told, I keep reading newspapers, some people say it could be revived, but only some people say only the lower levels can be revived. I really don't know. So I don't know the answer to your question. Essentially, it's by the government, and they had to do it. And as some of you may know, the group and some other scientists from different institutes in India, they wanted to do continue neutrino experiments. They tried to do it, they proposed what's called INO. And earlier they thought of doing it in the near Ooty, but environmental their problem. And later, this is near Madurai, near a place called Teni, yeah. And so they had almost started the work again. Several, I don't know, political, social issues, I think was, so they stopped the work. So I don't think, I don't know where exactly that experiment is today, but that is the story of neutrinos as far as TIFR is concerned. They did good work, but later all these things happened. Okay.
Okay. We have Professor M. Krishnamurthy who has raised his hand. MK, please go ahead with your question.
Thank you very much for a very nice presentation. I have a completely different question. I mean, of course, in the context of knowing about luminaries of TIFR. Today, TIFR is a very distributed system.
Can you be a little loud, please, Dr. Krishnamurthy?
Yeah, today we have, is it better now?
Yeah.
Yeah. See, today TIFR is a very distributed organization. We have, not everybody is able to have a chance to sort of breathe in TIFR Kolaba and, get bumped into some of these things and know a little bit more about this. And so how, and TIFR for most of the new students could be not really have the same meaning unless we make a good connection with the legacy of TIFR. And so how do you think this kind of thing should be better bridged?
Are you talking about relating students to the legacy?
Yes, because otherwise, TIFR becomes a university where some research is done, some degrees are obtained, and some skills are polished and move forward.
See, one thing I did not mention, I did talk about it when I said the end of innocence. My personal view, this is not an answer to your question, but I'm coming to that slowly. My personal view is that TIFR should have encouraged universities from the very beginning. Encouraged, of course, their contribution would be small. And so I mentioned the problem, for example, of manpower. I know how much we suffered, our groups, Sreekantan's group, suffered due to manpower shortage. Okay, we do, you know, so, as I said, some of us did all, but it's not finally very efficient, as you know. And it would have been much better if TFR had nurtured relations with institutes, with universities, however small they may be. So pick up few universities and pick up some group, some people from that. And so that would have also, I hope I'm not going to, in this time. Once I asked to meet professors from various MP universities when I was working in Pachmari. Some of them came and we had a talk, and they were all afraid of TFR. The idea was TFR is patronizing. So that thing actually put off university people quite a lot. So if we had done that, and now at least the collaborations, I'm told some of them are there with some of the university people. And I think they should grow. Otherwise, these experiments, to be very frank, are dying, okay, or will die soon. So now you're talking about the legacy and how to bring students into this thing. I actually, probably you are much better. That's almost 20 years since I left TFR. So I do not know, except, I don't know, some of you giving the type of talks I have given. Okay, and this is just about the field I am in, but you know more, you know about chemical physics, you know about solid condensed matter, etc., etc. You have to take them to universities, okay, and kind of we have to force ourselves upon them, and that's the only way we can build some bridges with the universities. And in TIFR itself, I myself, when I look back, the thing is there are some very important experiments done, but unanswered by other people in other groups, but very few people know about it. I agree with you. I do not really have proper answer to what you asked, but as I said, these type of talks, I mean, not just by me and by many people, would probably help. So I would like some younger people to ask if it is, they might be. So I'm sorry, Dr. Krishnamurthy, I don't know whether I fully answered your question.
Yeah, I think it's fine. I mean, it's a tricky sort of space in the sense of the modern day perspective. The students are coming from a completely different kind of perspective, and even within TIFR to make this kind of connection is important. And I was trying to see how
you see, for example, you see experimental activities, as you know, but now maybe slightly better, I don't know, were very unknown to us when we were students. Okay, and I'm sorry to say, even much later in TIFR, for example, the students had given liberty to look for, to go and interact with various groups and then choose their fields. But most people did not choose experimental activities. I myself ran an experimental course one particular winter semester. I was very surprised. These are all very bright people. Some of them had not seen oscilloscopes, and some did not know how to use it. So what I'm trying to point out is the divide starts there itself. And so even there, I don't know how many students who listen to our colloquiums, whether they came or not, but how many of them could relate to the activities we are doing. So, okay.
Thank you.
Do we have any other questions? Okay, so I think for now we don't have any questions both on YouTube as well as Zoom. So thank you very much, Professor Vishwanath, for this wonderful colloquium.
Thank you for inviting me. Yeah. I wish, as I said, younger people He was student. That was the whole idea, actually, when you and Dr. Krishnamurthy said to interact with the younger
Yes,
people. Of course,
absolutely.
physically it's not possible, but
actually, some
case,
of these kind of talks, I think if it was physical, it would be a lot more impactful and a lot more.
Probably, you're correct.
Connection.
Please call me after this COVID thing is over. I'll certainly, I'd love to come.
Sure. So we also thank Professor Grover and the attendees of the colloquium for participating in the same. With that, we come to an end of the event, and thank you so much for all your time. Yeah,
Thank you very
thank
much.
you.
Yeah.
Yeah.
Thank you.